In section 5.2, we want to talk about polar coordinates. The foundation of the polar coordinate system is a horizontal ray that extends to the right. And the end point of this ray is called pole, and this ray is also called the polar axis, which is extending to the right. And any point that's on this polar coordinate have the coordinates of r and theta instead of x and y. In polar coordinates, every point have r and theta as their coordinate. And r is the length of or the distance from the point to the pole, and theta is the angle that creates between the ray and the polar axis. So in polar coordinate system, we always show the points by r and theta. And as I said, r is the distance from the pole to that point, and theta is an angle from polar axis to the line segment from the pole to P. For example, if I have a point here, point P, and I want to find r and theta for this, since a polar grid is represented as a series of circles around the pole radiating out of the pole or the origin, each of these circles show me one number for r. So the first circle means the r is 1, the second circle when the r is 2, third circle is when r is 3. So since the point right now is on the second circle, that means the r must be 2. And theta, which is the angle between the x-axis and this ray, this angle, and for this point, the angle is 30 degrees. So if you want to write the coordinates of this point, you need to write point P with 2 and 30 degree. We can represent with the degree or with radian. We can write 30 degree or we can write pi over 6. And like unit circle, all of the positive angles are usually counterclockwise and the negative angles are clockwise. For example, if I have a point over here and I want to find the coordinate of these points, since it's on the second circle, so the radius is 3, and theta, or the angle that creates by this line from the x-axis, or this angle, which is 210. So 3 and 210 degree. These are the coordinates of the points on the polar coordinates. Let's look at the first example. It says plot the point with the following polar coordinates, 3 and 315. Okay, so 3 means the point is on the third circle. So you need to have a polar grid with at least 3 circles. 1, 2, 3. And 315 degree means that the point must be on the fourth quarter. So somewhere over here. So based on our information, r is 3, theta is 315. Okay, when angle is 315 degree and it's positive angle, we have to go counterclockwise, and since r is 3 and it's also positive, we have to plot the points on the same direction of the terminal side of the data. But what do we do if r is negative? If r is negative, we find the point on the opposite direction, and I will show you in next examples. And that is the point that we get. Example 2, we want to plot this point on the polar coordinate plane. So again, r is -2 and theta is pi. When theta is pi, that means the point must be on this line. And since r is -2, so 2 tells me that the radius is 2, means the point must be on the second circle. But what does the negative do? The negative tells me that I have to choose the point on the opposite direction. So for example, if you look at this point, the angle is pi, it's on the second circle, so this point is 2 and pi. But if the point that you want to plot it's -2 and pi, after finding +2 and pi, you go in the opposite direction and find this point, which is -2 and pi. We want to plot this point. The r is -1 and theta or angle is -pi/2. This time the angle is in radian. You can change it to degree if you want. -pi/2 means -90 degree. So this time both of the r and theta are negative. If r is negative, that means we have to find the points on the opposite direction. If angle is negative, that means we have to go clockwise to find angle. So if I have a circle, so r is 1, that means on the first circle, and theta is -90 degree, that means on this direction, so the points should be somewhere on this line. But since r is -1, if it was +1, the point was here, but if it's -1, we go in the opposite direction, which is above the x-axis. So you start with the angle. -pi/2 means -90. So you go clockwise and find -90, and which means your point must be somewhere on this part. Depends on what the r is. If r was 1, it was here. If it's 2, it's here. If it's 3, but if it's -1, we go opposite direction of +1. For +1, we had this point. For -1, we go in the other direction. So this point is +1 and -pi/2. You may say, okay, if I go in a negative direction, I get -90 for this point, but sometimes we can also find, another representation for this point. If I go in a counterclockwise direction, what are the coordinates of these points? So the coordinate of this point, if we look at the point in the counterclockwise direction, it should be 1 and 3pi/2. So which means this point can be represented as a y and -pi/2, and also can be represented as a y and 3pi/2. It depends where they ask us to find the point. Or for this point, we found -1 and -pi/2, but we can also, if we look at counterclockwise, we can say this point can be 1 and +pi/2. So it means these 2 points are in the same location. So we may have different representation for every point on the polar coordinate system. For example, in this example, it says find another representation of this point 5 and pi/4, which r is positive, still is positive, and the angle is between 2 pi and 4 pi. So right now, r is +5, but the angle is pi/4, but it's not between 2 pi and 4 pi. So if you want to have an angle between 2 pi and 4 pi, it means you have to go more than one rotation. So since r is 5, we need to show the points on the 5th circle from the origin. And since we want an angle between 2 pi and 4 pi, we need to add this angle with 2 pi because we need to find the same point for this location, but with an angle in between 2 pi and 4 pi. So we add pi/4 by 2 pi. And if we add pi/4 by 2 pi, we get 9 pi/4. So this point can also be And we can keep the radius the same, the r the same without any change. So these points also can be represented as a 5 and 9 pi over 4. So we may be able to find different representation for every point on the polar grids. Next example. This time we want to find another representation of 0.5 and pi over 4, which r is negative. We want the r be negative and also angle be in the first quadrant between 0 and 2 pi. Okay, if we want the r be negative, if I change the r to negative, it gives me negative 5 and pi over 4 without changing the angle. And I know that negative 5 is in the opposite direction. That means it's somewhere over here. That's negative 5 and pi over 4. But I want to get back to this looking point. Okay, because that's another point. When you want to find another representation for this point, that means the location must stay the same. Just the representation of the point must change. If I only change the r to negative, I get another point, this point. How can I get from this point to that point? As you see, from this point to that point, the angle between them is pi. It's half of the circle. So it means if I add the pi over 4 by pi, I will get back to this point. So let's see. If I add pi with pi over 4, I get 5 pi over 4. Okay, and we keep the r negative. So if I find this point on the polar coordinates, it should give me the same point as a 5 and pi over 4. So let's see. Let's find this point. We said to show the points, we need to find angle first. 5 pi over 4. So when you divide each quarter to 2, that means you have pi over 4. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, and 5 pi over 4. So that means I need to find a point on this part. If r was 5, I had this point, but since r is negative, I need to find a point on the opposite direction, which is this point. As you see, we get back to the first point. So this point also can be represented as a negative 5 and 5 pi over 4. Now let's see what are the relation between the polar and the rectangular coordinates. When we talk about the rectangular coordinate, means x and y axis. All the points represented by x and y. When we talk about the polar coordinates, that means we are talking about r and theta, which coordinates. So r and theta, every point will be represented by r and theta. Now, what relation there is between r, theta, x, and y? So if this is a point on the rectangular coordinate, it has a x and y as its coordinate, which means this is y and this is the x of the point. But if the point is in the polar coordinate, it has r and theta, and we know r is the distance from the point to the pole, and theta is the angle that creates by that ray. Now we can find a right triangle, and every property that we had in the right triangles that works here. And as you see, we can say the tangent of this angle based on the right triangle property is opposite over adjacent, which is y over x. So the tangent of this angle is always y over x. We can also use the Pythagorean theorem. We say r squared, or the hypotenuse of this triangle, it's equal to the x squared plus y squared. We can also say that the sine of this angle is opposite over hypotenuse. So the sine of angle theta is y over r, and if I do the cross multiplying, y is equal to r sine theta. And the same for x, which is equal to r cosine theta, because cosine of that angle is adjacent over hypotenuse. So these are all the relation that we have between x, y, r, and theta. Why do we need to know them? Because sometimes they give us a point in the rectangular coordinate based on x and y, and they ask us to find the polar coordinate of that. Or vice versa, we will have a point on the polar coordinate, and we need to convert it to the rectangular coordinate. Let's look at the next example. But we know that every time we have a point on the polar coordinate and we want to convert it to the rectangular coordinate, we use these two. X is equal to r cosine and y is equal to r sine. In this example, we want to find the rectangular coordinate of the point with the following polar coordinates. The polar coordinates are 3 and pi. And we want to convert it to the rectangular coordinate. Rectangular coordinate x and y. So we need x and y. So what do? We know that the r is 3 and theta is pi. And we also know that the x is r times cosine theta. Okay? X is r times cosine theta, y is r times sine theta. And if you replace the r by 3, replace the theta by pi, we know that the cosine of pi is -1, and -1 times 3 is -3. If we replace r by 3 and the theta by pi, we know that the sine of pi is always 0, and 0 times 3 is just a 0. Now we have the point in the rectangular coordinate, and the coordinates are -3 and 0. Next example, we have another polar coordinate, and we want to convert it to a rectangular coordinate. So we know that r is -10 and theta is pi over 6. Again, every time we have polar coordinate, to convert it to rectangular, we use those formulas. X is equal to r cosine theta, y is equal to r sine theta. So x is equal to -10 cosine of pi over 6, and y is -10 sine of pi over 6. Pi over 6 means 30 degree, cosine of 30 degrees is √3 over 2, and if we multiply by -10, since we can simplify, we will get -5√3. And sine of pi over 6 or sine of 30 degrees is 1/2, and if we simplify 10 by 2, we get -5. So the rectangular form of this point is -5√3 and -5. So out of these 4 relations that we learned on this slide, so remember, we always use this one to convert from polar to rectangular, and we use these two to convert from rectangular to polar. So how we can convert from rectangular to polar? As I said, we are going to use those two formula, but you can also plot the point to make sure that you have the correct x and y. So let's look at next example. We want to find the polar coordinate of a point whose rectangular coordinates are 1 and -√3. When it says the rectangular coordinates are 1 and -3, that means x and y is given to you. When you want to find the polar coordinate, that means you want to find r and theta. So first of all, step 1, we want to plot the point on the coordinate plane. Okay? And then we need to find r by using the formula r is equal to square root of x squared plus y squared. So plot the point. X is 1, y is -√3, which is √3 is about 1.7, so it's negative in negative direction and gives me this point. Okay, so now I want to find the r by using the formula. R is equal to x squared plus y squared, and replace the x by 1 and replace the y by -√3. 1 squared is just 1, Root 3 square is just 3, and 1 plus 3 is 4, and the square root of 4 is 2. So we found the r. Now is step 3, we need to find the data. And how do we find the data? By using the tangent of data, which is equal to y over x. So y is negative root 3, x is 1. So the tangent of data should be equal to negative root 3 over 1, which is negative root 3. And now we need to find the data. You can use the inverse tangent if you don't know the answer. So you can just put this one in calculator and see what angle its tangent is negative root 3. Or you can use the table that's provided for you. And you know that root 3 is also the tangent of pi over 3. And using the reference angle, you can find that the theta must be 5 pi over 3 because tangent is negative. And only quadrant that the tangent is negative are quadrant 2 and quadrant 4. So the angle must be in quadrant 4. That's the angle. And if you plot the point first, it gives you an idea where the angle is. So the angle must be in quadrant 4. And in quadrant 4, for sure, it cannot be pi over 3. It should be 5 pi over 3. Okay? Now, after finding r and data, we can rewrite the point as 2 and 5 pi over 3, which is the polar coordinate of that point. Let's look at another example. We want to find the polar coordinate of the point whose rectangular coordinates are negative 2 and 2. So x and y are given to us. We want to first, let's plot the point. If I want to plot the point on the coordinate plane, x is negative 2, y is positive 2. So that's the point. And if I connect this point to the origin, I know that this distance is r and this is the angle theta. So if you want to find the polar coordinate, that means you want to find these r and these theta. And when you plot the point, it gives you an idea where the angle is. And based on the quadrant that the angle is, you can find the angle correctly. So let's find r by using the formula. X is negative 2, y is positive 2. Negative 2 squared is just positive 4. 2 squared is 4. 4 plus 4 is 8. And if you, since you know 8 is 4 times 2, so the 4 can be out as a 2. So the final answer in simplified form is 2 root 2. Now it's time to find the angle. And I'm going to use the other formula for tangent of the data. That tangent is always y over x, which is 2 over negative 2. And if I simplify 2 by 2, the answer is negative 1. Okay, tangent is negative. So I know that the angle must be in quadrant 2 or 4. But if I look at the picture that I already graphed, I know that the angle must be in quadrant 2. So, but to find that angle, first ask ourselves, the tangent of what angle is 1? If you look at the table, you know that the tangent of pi over 4 is positive 1. So if it's negative 1, that means 1 pi over 4, 2 pi over 4, 3 pi over 4. So the angle must, in quadrant 2, must be 3 pi over 4. You can also put it on the calculator using the tangent inverse key and see what you get. Now you have both of the r and data. You can rewrite it as polar coordinates, which are 2 root 2 and 3 pi over 4. We can also convert a rectangular equation to polar equations or vice versa, or polar equation to rectangular. Everything is the same as the points. If we have polar equations, and we if you have a rectangular equation and which is in terms of x and y, and we want to convert it to the polar equation in terms of r and theta, we are going to replace the x by r cosine and y by r sine. But sometimes in some equation, you may not be able to find or see r cosine and r cosine, when you're looking at the equation. Sometimes you need to make them first. Based on the equation, sometimes you may need to multiply by r, sometimes you may need to square both sides, sometimes you need to so as I said, square both sides or multiply by r, or so you do some changes that to provide these parts, r cosine and r sine, then you will be able to replace r cosine by x, r sine by y. Now your equation should be in polar form or the rectangular form. So it depends on the equation. We will discuss in the examples. For example, I have a rectangular equation here, which is 3x minus y is equal to 6. This is a rectangular equation because it's in terms of x and y. And I want to convert these to the polar equation. I want to change everything in this equation in terms and change it in terms of r and theta. Okay, I know that I can replace x by r cosine and y by r sine. Okay, so let's do that. Let's replace the x by r cosine and the y by r sine. So 3x means 3r cosine, minus y means minus r sine, which must be equal to 6. But we can't leave the equation like that, because most of the time when we talk about the equation, in the equation, one variable is based on the other variable. We always have one dependent, one independent variable in the equation. And you know that in rectangular equation, we always have y by itself on one side and the rest of the equation on the other side. So to make in that form, I prefer to keep the r by itself in one side in this equation and move everything else to the other side. To do that, I need to factor out the r from these two. If I factor the r, I will get 3 cosine from the first term, a minus sine for the second term. Now, to find the r and isolate the r, I just need to divide both sides by the parenthesis. So it gives me r, which is equal to 6 over 3 cosine minus sine. Now I have an equation in terms of r and theta, which means it's in the polar form. So these two equations are same, but one is in the rectangular form, one is in the polar form. Another example, we want to find this rectangular equation to polar equation again. So every time we have x and y in the equation, it's easy to replace the x by r cosine and y by r sine. The other direction, it's a little difficult, changing the polar to the rectangular, because we may not have all of the r cosine and r sine at the same time in the equation, and we need to provide them first. So let's replace the x by r cosine and y by r sine. Don't forget that we have to keep the squares. Now we need to square each of these parentheses. So the first parenthesis has only one term, r and cosine, because they are multiplying. So we just multiply both of them with the square. So we have r square and times cosine square. But the second parenthesis has two terms. And when we have two terms inside the parenthesis and we want to square the parenthesis, we need to rewrite the parenthesis 2 times and multiply it by itself. So r sine plus 1 times r sine plus 1. And then multiply everything together. And we get this one. So r sine times r sine is r squared sine squared. R sine times 1, r sine times 1. Combine the like term, it gives us 2r sine, and 1 times 1, which is 1, and bring down the other side of the equation. Now, when I'm looking at these two equations, these two terms, I see that r squared is in common between these two. So we can factor out r squared and see what happens. If I factor out r squared, inside the parenthesis, I will only have cosine squared plus sine squared. And I know in trigonometry, cosine squared plus sine squared of any angle is always equal to 1. So if I replace that by 1, I will get r squared plus 2r sine plus 1, which is equal to 1. Now this equation, to simplify this equation, I see that I have an equation which is actually a quadratic equation in terms of r. Because I have r squared, I have r, and I have a term without r. And I know to solve any quadratic equation, I have two options, using the quadratic formula or factoring method. But for both of them, I need that everything is in one side and the other side be 0. So to make the right side 0, I'm going to subtract 1 from the both sides. And if we subtract 1 from the both sides, these two cancel each other and it gives you 0. These two also cancel each other. So you only have r squared plus 2r sine, which is equal to 0. Now, since I only have two terms, factoring is the easiest way. So I can factor out r from the two terms, and then these two are equal to 0. That means each of them separately can be equal to 0. I can set this one equal to 0 and this one equal to 0. If r is equal to 0, that's the equation. Just leave it. And if r plus 2 sine is equal to 0, you can isolate the r by moving 2 sine to the other side. So you have this equation. Now you converted this rectangular equation to two polar equations. Which one of them can be the answer? R equals 0 or r equals negative 2 sine theta. Now, if we want to convert from polar to rectangular, we're going to use the other formulas. We actually need to know all of them, but we need to know which one works better in our case. So let's see what happens. As I said, for this case, you may need sometimes s squared both sides, because if you want to use this formula, you need r squared. If you don't have r squared, you need to s squared both sides. Sometimes you need to replace some other identities. Sometimes you may need to take tangent from the both sides if you want to use this formula, for example. Or sometimes you may need to multiply both sides by r to get one of these cases. So based on the problem, you may need to do some steps before using any of these formulas. For example, I want to convert this polar equation to rectangular equation, and my polar equation is r equals 4. So I don't have any equation for r. If it was r cosine, I could replace it by x. If it was r squared, I could replace it with x squared plus y squared. But this one only have r. Not r squared, not r cosine, not r sine. So what we can do? We can s square both sides first to get r squared. That's the easiest one. Because if I want to multiply by sine and cosine, I need to do it on the both sides. And the sine and cosine on the other side, it may make problem for me for simplifying or anything else. So the easiest way is to s squaring both sides to r. Both sides to get r squared. So if we s square both sides, we get r squared, which is equal to 16. Now, since I have r squared, I can replace the r squared by x squared plus y squared. And I'm done, because right now I have an equation in terms of x and y. There is no more r and theta. And we know that the x squared plus y squared equal to r squared is always the equation of a circle, which the radius of the circle is r. So this equation is the equation of a circle, which the radius of this circle is 4, because 16 is 4 squared. And if you want to graph it, you need to graph a circle with radius 4. And that blue circle, it's the graph of this equation. Okay, another example. You want to convert this polar equation to rectangular equation. This time the equation has only data, but out of the formula that we don't have any formula to replace for data. If we had the tangent of data, we had a formula for that, but not the data. But we can take tangent from the both sides. If we need tangent, we can take tangent. But remember, everything that you do on the left side, you need to do the same on the right. So if you're taking tangent from the left, you need to have a tangent on the right as well. So we say the tangent of data must be equal to the tangent of 3 pi over 4. And what's the tangent of 3 pi over 4? So we know that 3 pi over 4, 1, 2, 3 is over here. That's 3 pi over 4. And the reference angle is pi over 4, which means the tangent of 3 pi over 4 must be the same as the tangent of pi over 4, which is 1. But since this angle is in the second quadrant tangent is negative, so the answer for this one is negative 1. Okay, so tangent of data must be equal to negative 1. But we know that we have this formula for tangent. Every time we have a tangent of data, we can replace it with y over x. So let's replace tangent by y over x, and we get y over x, which is equal to negative 1. And if we cross multiply this, we get y times 1, which is y, equal to negative 1 times x, which is negative x. And we are done, because right now we have an equation in terms of only y and x, which is in rectangular form. And to graph this y equal negative x, you know that the y equal negative x is always a line, and we can graph the line, which you see it is passing through 3 pi over 4 as well. Next example, we want to convert this polar equation to rectangular equation in terms of x and y. The equation is r equal negative 2 secant of data. Okay, the formula that I have to replace for r, cosine, sine, x, y, none of them has a secant. We have tangent, we have r cosine, we have r sine, but we don't have anything about the secant. So that's why, as a first step, I try to replace secant by an identity to change it to one of the sine and cosine. And we know that the secant is always 1 over cosine. So we can replace the secant by 1 over cosine. And if we replace it with 1 over cosine and multiply these two, we get negative 2 over cosine data. Now let's see what we can do. Out of the formulas that I have to replace, I know that r cosine can always be replaced by x. Can I create r cosine? Yes, if I multiply both sides by cosine, these two cancel each other, and the other side gives me r cosine, which is equal to negative 2. Now I have everything ready to replace, and I know r cosine is always x, so the equation is x equal negative 2. And if you want to graph x equal negative 2, you know that on the x-axis we find negative 2, and we will have a straight vertical line for that. And you can see it on this polar grid. And the last example, to convert this polar equation to rectangular equation, we have r equal 10 sine data. Okay. I remember the formulas that I have. The formulas tell me if I have r times sine, I can replace it with y. If I have r squared, I can replace it with x squared plus y squared. But none of them works here. But we may be able to create this one. How? By multiplying both sides by r. If I multiply both sides by r times r on the left is r squared, and r times 10 sine theta is 10r sine. Now this one will be replaced by y, and this one can be replaced by x squared plus y squared. Now I have everything ready to be replaced by x and y. So r squared, which is x squared plus y squared, must be equal to 10y. Okay. Can we simplify this equation more? Well, let's see. First of all, let's move everything in one side. And if I move 10y to the left, I will get x squared plus y squared minus 10y, which is equal to 0. I can't do anything with x squared because there is no more x, but what about these two? What we can do with these two? Because you know that in polar coordinates, the equation of a circle is always x squared plus y squared equal to r squared. So if we can create an equation of a circle, that would be helpful to have a graph of this equation. I have the x squared ready here, but what we can do with that part to make it only to something squared, not having y squared minus 10y. Which means I want to make a perfect square out of the y squared minus 10y. How do we make a perfect square? We always look at the number in front of the y. Divide that number by 2 and square that. It gives me 25. It means if I add 25 to these two terms, I can easily factor it out and rewrite it as a y minus 5 squared. But if I'm adding the left side by 25, I have to do it exactly the same on the right. So I'm going to add 25 to the both sides first. And these three can be factored in this form and rewrite it as a perfect square by just squaring the first one, squaring the last one, and use the sign of the middle one. Everything goes inside the parenthesis and the power goes out of the parenthesis. And that 25 on the right side, since there is no other like terms to add or subtract, we keep it without any change. Now I have an equation. Still this is the equation of a circle. But the equation of a circle, which the radius of a circle is not origin because of the parenthesis that we have here. The radius of the circle is 5. But we have that equation in forms of x and y, and you can see the graph here. We have an equation which the radius is 5 because of these 25, and the origin or the center of the circle is 0 from x and 5 from y. 0 and 5. If you find 0 and 5 and create a circle with radius 5, that should be the graph of this equation. So more information about graph of circles, we always have x minus a squared plus y minus let me just put h k squared, which is equal to r squared. That this is always an equation of circle. A circle which the center is always h and k, and the radius is always r. So in this equation, there is no parenthesis here, which means the h is 0. We have 5, which means the k is 5, so that's the center of the circle, and the radius, which is